Hello all, I, Dr. Nidhi Sharma, Assistant Professor Chemistry, AISSMS, Institute of Information and Technology, welcome you all in today's lecture. Today's topic is corrosion science. As you can see in the picture, due to the corrosion, heavy materials, building materials, heavy machineries, all just get distorted due to the corrosion. Now, the points to which I just want to discuss in this topic is the definition, the types of corrosion, factors affecting the rate of corrosion, and method of corrosion control. So, one by one, we are going to discuss all these topics. Now, the first thing, what is corrosion actually? So, corrosion is actually it is a destruction or deterioration of metal by chemical or electrochemical attack of environment, starting at a surface. Now, next point is what is the reason of the corrosion? What is the cause of corrosion? So, corrosion is due to the thermodynamic stability. This I will discuss. Most of the metals actually occur in the nature in compound state, like in the form of oxides, chlorides, hydroxides, sulfides, carbonates, silicates, etc. Except few noble metals like silver or platinum. So, actually, what happened? These all the metals are present in the form of ore, and in the ore form, these are in thermodynamically stable form. But when we want to get the pure metal, the metallurgy takes place, and with the help of metallurgy, we get the pure metal. But during the process of processing of metallurgy, the overall energy of the metal increases, and due to increase in the energy, the thermodynamic stability of the metal decreases. Now, to get the stability again, this metal is going to react with atmospheric gases, atmospheric moisture, and it will convert into the corrosion compound. And finally, it will get converted into a thermodynamically stable form. So that's why the corrosion occurs, to get the thermodynamic stability. Now, the types of corrosion depends on the type of atmosphere. The corrosion is of two kinds: dry corrosion and wet corrosion. Dry corrosion is also known as direct or atmospheric. Wet corrosion known as electrochemical or immersed. Then again on the type of the gases, these are further classified. So one by one we are going to discuss it. Now dry corrosion, it occurs due to the chemical reaction between metal and the atmospheric gases which are present in the atmosphere. And wet corrosion is occurs due to the electrochemical reaction between metal and electrolyte, which can be aqueous salt solution, which can be acid, which can be alkaline. Any type of the medium is present, then the wet corrosion is up. Now, first I will discuss about the dry, direct, or atmospheric corrosion. Now, as already we have discussed that why it is called the dry corrosion. Dry corrosion means when the gas attack takes place. So, what type of gases can actually attack? The CO2, O2, H2S, halogens, any type of gas can react with the metal surface. So, in all the gases, what is important? There are two important factors: chemical affinity between the metal and corrosion environment, and second, ability of reaction product to form the protective layer on the metal surface. So, these are the two important factors on which the dry corrosion depends. So, as already I have told you in the beginning, like the dry corrosion is of two kinds: corrosion by oxygen, corrosion by other gases, corrosion by liquid metal. So, first we will discuss the corrosion by the dry oxygen gas. This is also known as oxidation corrosion. The oxidation corrosion is brought about by the direct action of oxygen on metal surface at very low or high temperature, usually in the absence of moisture. So at ordinary temperature, when metals are slightly attacked by the oxygen, alkali metals like sodium, potassium, alkaline earth metal, barium, beryllium, calcium, magnesium are rapidly oxidized at very low temperature. And at high temperature, all metals except silver, gold, platinum get oxidized. Means at low or at high temperature, at both the temperature, the metal oxidized to get converted into the metal oxide. So how it happens actually? As you can see, The metal oxides are formed during the oxidation process where the metal, it will get oxidized, it will lose the electron, and that lost electron will be accepted by the atmospheric oxygen, which is going to get converted into oxide. So finally, the net reaction is this metal ion and oxide ion together form the metal oxide. So what is the mechanism actually? Corrosion takes place in three steps. So the first step is the adsorption of atmospheric oxygen on metal surface. So molecules of oxygen adsorb. As you can see here in the picture, the molecule of oxygen get adsorbed rapidly on the surface of metal. And atoms of the metal at its surface have some free unused vacancy. So these atoms hold the oxygen molecule very firmly, very strongly through their free valencies. So this is the adsorption of the metal, but this adsorption happens only on the metal surface. So it is just only purely a physical phenomenon. Then step 2 is the dissociation of oxygen molecules into atoms. So slowly, especially at increased or high temperature, adsorbed oxygen gas molecule, it dissociates into atom. From molecules to atom, it gets converted to atom. In third step, the loss of electron by metal atom forming metal ion, and the electrons are gained by oxygen atom to form oxide ions. So actually the electron exchange takes place. So what happens? The metal will lose the electron, it will convert into metal positive ion. Oxygen will accept electron, it will convert into oxide ion. So here as you can see on the surface, the positive ion of metal and the negative ion of oxide. Now in step 4, formation of metal oxide at surface. Now when these metal ion or oxide ion combine together, these form metal oxide, and thus the metal oxide formation, a thin film just get formed over the surface. So initially the oxidation occurs at the first surface of the metal, resulting in the formation of metal oxide, which is in solid form. Now for oxidation to continue, either the metal must diffuse outwards through the scale or the oxygen must diffuse inwards. So it means the uh, whether the corrosion will continue inside the metal or it will remain on the surface, it actually depends on the type of metal. So, nature of oxide film which are formed are of four kinds. The first is the porous oxide film, second is non-porous oxide film, third is unstable oxide film, and the fourth one is volatile oxide film. So, one by one we will discuss. As you can see in the picture, this is the layer of the, this is a picture of non-protective oxide film, this is protective. So the alkaline earth metals form oxides having less volume than the volume of the metal. So therefore volume of oxide form is insufficient to cover where the volume of metal oxide form is insufficient to cover the whole metal surface. So what is going to happen? The space which is unoccupied, the oxygen will react the second layer of the metal. So in this way, the whole metal will get corroded. As you can see here, sodium, iron, magnesium, these are the examples of the porous oxide film. It means the porous oxide film means the oxygen gas further can interact with the rest of the metal. Now, in case, it means the whole metal which is underlying, it is going to get corroded. Now, in case of non-porous oxide film, which forms the protective layer, metals like aluminium, chromium, copper, these forms oxide whose volume of oxide layer is greater than the volume of metal exposed. So, therefore, these oxide film do not have any crack or pores and form barrier for further attempt. So, as a result, corrosion is discontinued once oxide film is produced at the surface. Example is like as you can see, aluminium from aluminum, copper, zinc, chromium. These are the example of the protective layers. Then third one is the unstable oxide film, which is the example like silver, gold, platinum. These are the metals. When the oxide film form is unstable. So it decomposes back into the metal itself. Like oxide will form, then again it will get converted into metal. And the fourth one is the volatile oxide film. When oxide film form is volatile, it vaporizes as soon as it is formed. The underlying metal surface is again exposed for further attack of oxygen and cause continuous excessive corrosion of the metal. An example is molybdenum. Molybdenum is the best example of the volatile oxide film. So, what actually governs this formation of the oxide layer? There is filling backward rule. It gives the idea about the nature of oxide. So, what is PBR, filling backward ratio? The volume of metal oxide formed divided by the volume of metal consumed. So, as already I have told, again I am telling this about this. If the volume of oxide film is smaller than the volume of metal consumed, then the film will be porous, non-protective. And if the metal oxide form is greater volume than the metal consumed during corrosion, then it will be a non-porous or protective layer. Now, further, according to this rule, if it means the PBR is less than 1, then oxide film will be too thin. So therefore it is porous. If the PBR is more than 2, then oxide film will chip off. If the PBR will be more, then again it is not good. If it is more than 2, oxide form, chip off or cracks, this provide no protective effect. Example, iron. If PBR is within 1 to 2, means like as you can see, if PBR is more than 1 but less than 1.45, then it is going to form the protective layer, non-porous protective layer. So this is filling backward rule. Now the second type of corrosion is the corrosion by liquid metal. So corrosion by liquid metal, it means the liquid is not the medium. So here the corrosion is due to the chemical action of flowing liquid metal on solid metal or alloy at very high temperature. The corrosion reaction involves either dissolution of solid metal by liquid metal or internal penetration of liquid metal into the solid metal. Metal goes inside the solid metal, liquid metal. So such type of corrosion is found in the devices just like the nuclear power generator. Now the third kind is the corrosion by other gases. What other gases can be responsible for the corrosion? The other gases responsible are the carbon dioxide, H2S, chlorine. For example, silver form a non-porous film. So it is protected here, silver sulfide. Where tin form the porous film, non-protected, that means the corrosion further continues. So now in this corrosion, we will discuss about the corrosion by hydrogen. So corrosion by hydrogen, again we divide it in two parts. The action of hydrogen gas on metal occur by two ways, namely hydrogen embrittlement and hydrogen attack. So first, what is hydrogen embrittlement? When hydrogen gas attack the metal at ordinary temperature, it is known as hydrogen embrittlement. And why? It is due to the formation of atomic hydrogen as a result of chemical or electrolytic action occurring at the metal surface under the specific condition. For example, as you can see, the presence of aqueous solution of H2S in the system causes the evolution of atomic hydrogen gas, and this is happening at the surface. Now this evolved atomic hydrogen diffuses readily into the metal and collected into the voids where it recombines to form hydrogen gas. So the formation of atomic hydrogen, diffusion into metal, then collection into the metal voids, and finally formation of molecular hydrogen continue, and the presence of hydrogen inside metal voids continue to increase till this pressure become very high. So it causes the formation of blister on the surface. This affects the strength and ductility of the metal, and it causes the brittleness of the metal. Now what is hydrogen attack? At very high temperature, hydrogen attack is due to the diffusion of hydrogen gas into the metal. Atomic hydrogen is formed at thermal dissociation of molecular hydrogen, which is chemically very active. So at high temperature, it combines with the elements like carbon, sulfur, nitrogen, which are present in small amount in metal. For example, if atmospheric the atomic hydrogen combined with carbon, it is going to form this methane gas. And this, the formation of methane gas, it again causes the blistering formation and it reduces the strength of steel and makes it brittle. So thank you all.